Octave for Calculus 2. Today we're going to look at conditional statements and random numbers. So you'll be receiving this PDF file, which is the Octave notes. It's 23 pages. It goes back to Calculus 1, where this is what we learned in Calc 1. And I do have videos that will help you review this material. And then when we get to Calc 2, we start with if-then statements. These are called conditional statements. So let's take a look at this little script here. So I recommend you try Octave online. Just search on Google for Octave online, and this will come right up. All right, let's run this. So it's waiting for me to enter values. Let's see. Oh, I have to save this. Okay, so when you enter a script, just entering it doesn't save it. If you don't save it, it won't run properly. What it's doing here is it's running a previous script that all it did was print out hello world. So let's save it. All right, now let's try to run it. All right, enter A, 3. Enter B, 5. So it divided A over B and displayed the answer. But let's say B was 0. So let's say A is 3. And B was 0. Well, it triggered an error, an exception. You can't, of course, divide by 0. So it would be nice if we could check to make sure that B was not equal to 0. So the way that we do that is with an if-then type statement. So the syntax is right over here. If condition, do statements, and if. So if the condition is true, it will execute what's in here. So let's check it out. So let's add. Okay, so let's save it. So if B double equals 0. So that probably looks a little strange, but you must use the double equal sign because the single equal sign is used to set the value of a variable. So for example, A equals 4. Display A is 4. But if you say something like B, A double equals 4, it says the answer is 1. So what does that mean? Well, true is 1 and false is 0. So if we say A double equals 3, it says that's false. So 0 is another way of thinking of false, 1 as true. That's called a Boolean variable, true or false. So you can say A is true and B is false. And then you can say if A display for end if. So I'll show it to you here. It'll be a little easier to understand. Okay, so if b is equal to 0, so the double equal sign means checking whether something is equal to, but it does not set b equal to 0, then display the variable shouldn't be 0. And this end if ends the if block. So these statements all go together. And if b is equal to 0, we don't want it to actually do this, right? So it would make sense to put an else here. So let's see. So let's try this out. So for A, 3, for B, 0, and it simply tells us B shouldn't be 0. Let's try it again. Let's say B is 2. It did it correctly. Alright, so this is giving brains to a computer. It's allowing it to think a little bit. I mean, of course, computers don't really think, but what's happening here is the computer is checking whether the variable is 0, and if it is, it does one thing. If it's not, it does something else. Notice the end if that finishes off the if and the else block. Alright, so you can put other things inside the if statement. So if you want to check if x is less than y, x less than y, greater than y, so less than or equal to, it looks a little funny, but you need to put them both. So 3 less than equals 4, true. So 3 less than equals 4, that's true. 3 less than equals 3, that's also true. 3 less than equals 2, that's false. So 0 is false. We already talked about this. Not equal to. So if you want to check if x is not equal to something, use the exclamation equal. So you can reverse the logic here. See? You can say if b is not equal to 0, then execute this. Else, execute this statement. So it's the same program, we just reverse the logic a little. Alright, so A is 3, B is 0, A is 3, B is 4, so it works as expected. Okay. Alright, so we ask the user to enter when you were born. If the year is greater than 2016, we say we don't want you to enter that value. Okay, so this is the absolute value function. So let's delete this. All right, so the reason I started this script with the words format long is because of a technicality with Octave. If you start the first line as a function, then the name of the file has to be the name of the function. So one way to avoid that is to just put anything else on the first line except the word function. It's not a big deal, but it's just a technicality. All right, so this is a function that implements the absolute value, and let's check it out. Display absolute so display absolute of -2, and let's try it with +2. So first it reads this function, it learns it, and then we use the function that we just defined. And see, the answer is 2 and 2 on both counts. So if the number is positive, so we say the answer to the function is x. What's the absolute value of 2? First, say it's 2. If x is negative, flip the sign. So if x was -2, it would flip the sign to a +2. But if x was already positive, this would never get activated. So the answer would remain, the function would remain the +2. All right, so we already looked at if-then-else statements, and we went a little bit ahead and coded that already. Okay, how to check if a number is even or odd. So let's see what we can do here. And in fact, we can even do something interesting, put it in a for loop. For z equals 1 to 20, see, it's good to indent so you can keep track of the structure of your program. And for. All right, let's try it out. All right, so let's try printing z. All right, so they didn't like the way we printed here, so we're going to have to do it this way. So display z, display is even. All right, let's try this out. So if, when we divide z by 2, if the remainder is a 0, then it's an even number. So remainder means the remainder after dividing by 2. Else, that means it's an odd number if when you divide by 2, the remainder is not 0. So let's try this one out. All right, so now at least we have our numbers. 1 is odd, 2 is even. If we change this to the word display, let's see what happens. So no change. So you can use display or dis. All right, so piecewise defined functions can be defined with if-else. So if we want to code this function right here, well, if x is less than 1, this is the rule. If x is greater than or equal to 1, else, this will be the rule. Don't forget what that dot means. So the dot means, for example, say x equals 1 to 20, or x equals 1 to 5. All right, so this is a list with 5 numbers. And if you say something like x squared, it doesn't like that. It's an error. If you want to square each number, remember you need the dot square operator. So the dot goes through each element of your list. Okay. So this little function here simply converts distance in feet and either to meters or centimeters. So let's take a look. We didn't want the line to end. So see how there's no line number here? This line really continues. Even though it looks like it's 2 lines, it's really only 1 line here. All right, let's try this out. Enter distance in feet, 100 feet. So we want to convert it to centimeters or meters. Let's try centimeters. 3,048. Let's try it again. 100 feet. Let's try meters this time. All right, so hopefully this is pretty simple. If our choice is 0, if we entered a 0, remember this is how the user enters values. It executes this. Otherwise, you entered 1 or anything other than 1. See, if you entered anything other than 0, it would still do this. Right? Try it out. Enter 5. So it's not 0. So if it's not 0, it does that. All right. So I introduce arrays in another video, which I'll give you a link for. All of this is done there. And let me jump to what's not in that video, and that's random numbers. So random numbers are really neat because you can use them to model random events in real life. All right, so let's take a look at this code here. So the first step is declare an array, a list of 10 numbers, and fill them with 0. So let's take a look at some of these commands. All right. So let's look at ARR. So notice we have an array with 10 numbers. Now let's say we say that x equals rand parentheses. And keep doing this. See, it chooses a different random number between 0 and 1 each time. Okay, so you get the point. All right, so this code here will fill up a list with 10 random numbers. We start out with them as 0, but then we set the ith element in the list equal to rand. All right. So there was no output, so let's see the output. So for I equals 1 to 10, display array I, the ith element of the array, and 4. And so there are our 10 random numbers. What if we wanted the random numbers to be between 7 and 11? Well, this handy formula would work great. We'll just rescale with a linear function. So let's see. Remember, that's a comment. So now Octave won't run that line of code. So let's say A equals 7, B equals 11. And remember, the semicolon suppresses output. Okay. So let's use this command here. All right, so there we go. Instead of just a random number between 0 and 1, we're going to rescale the net random number. All right, so let's try this out. All right, we made a mistake. Syntax error. Let's see what's wrong. That looks good to me. Maybe it doesn't like this. Let's see if that's wrong. Now, still saying there's something wrong with this B minus A over here. Let's try it out here. So let's try with numbers. 7, 11 minus 7. This is very strange. Let's see. Rand. Right. See, we can multiply rand by the number 4. And that seems to be working. We can take numbers and subtract them in a parentheses. That seems fine. So let's see. 11 minus 7 times rand and add 7 to it. Seems to be no problem. It might be when I copied and paste There could be some invisible character there or something. Let's see. So let's try to figure out our error. So this is good. You'll see a little bit of how to figure out an error. Let's go back to what we had before. All right, so that works. So let's try A times all right, that worked. B plus, so let's try A plus B minus A. All right, so it works now. It might be when I copied and pasted, some strange character showed up there. Maybe that period there at the end or something. Just a little bug, but everything seems to be fine now. All right, so notice we have random numbers between 7 and 10. Those are decimal numbers. All right. Now you can also get a random integer. So take a look at this little program here. Let me just fix the formatting. All right, so we have a new function here called the randi, and let's figure out what it does. Save. Line 8, there's an error here. Oh, we forgot to end if. Okay. All right, guess an integer between 1 and 100. 42. Wrong. Try again. 56. Wrong. So, what does the randi do? Well, randi of 4. Look at the output. So it looks like it gives us a random number between 1 and 4. I think you can give it 2 values. Oh, interesting. When you do this, it actually gives you a matrix of random numbers, 4 by 4 matrix. Octave is actually set up to work with matrices. Now let's see if we can fix this guessing game to be a little smarter. Alright, so there's something called well, let's give ourselves a lot of guesses. For I equals 1 to 100. Now, I don't think we'll need all these guesses, but just in case, let's give ourselves a lot of guesses. All right, and 4. Now, if we guess it correctly, we want to exit out of this loop. So there's something called break. That'll break out of the for loop. Else, well, let's see how close we are if we're too big or too small. So let's see. So if, so let's copy this here. So if guess is greater than number, display too big. Else, display too small. Let's end this if. This end if goes with that if else. So these are nested end ifs. All right, so let's try this one out. All right. So guess an integer between 1 and 100. Let's try the midpoint. Something is wrong, right? We didn't wait for another guess. We need to put another guess inside our loop. So let's go back and fix our program. We need another guess. So if we guess wrong, where should it go? Should it go here? Before here, here, here? Correct answer is right over here. Because you want to guess after we get our hint. Let's try again. Let's try 50. Too small. Our guess was too small, so let's try 75. Somewhere between 50 and 100, right? Too small again, so let's try 88. Too small. Let's try 95. Too small. 97. Too big. Well, let's see. If it was 95 was too small, 97 was too big, 96. So notice it didn't take us too long to guess it this time. All right, so this is a pretty sophisticated program already. Don't worry, I probably won't make you write something this complicated on the exam. But just to show you, we could also store our guesses. So guess list equals zeros 100. So now we can store our guesses right here. So each time we do a guess, we can store it. So guess list well, it looks like we need maybe 101 at most, right? So guess list of 0 equals our guess. And then after we guess a number, we'll do something similar. Oh, actually, sorry about this. Octave likes you to start arrays at 1. So put a 1 here. And this one will be I plus 1. Remember, I starts at 1, so the first one would be 2 inside the loop. And then we can, when we finish this, we can print out I equals 1 to 100, 1, display guess list I, and 4. All right, so now we can store our guesses in a list. Let's try 50 again. Too small. Too small. So looks like we figured it out. And these are our guesses. Now, it is a little odd that we're getting numbers close to 100. There's no reason to expect it to be. So let's try it one more time. 50. Too big. Okay. Too small. Too big. Oh, we got it. So, and we got it at 30, and this only took us 4 guesses. All right, I hope you enjoyed this Octave video, and you're required to watch the other ones on arrays and for loops with arrays. Between these 3 videos, that should cover Octave, the basic Octave for this course.